What we also have in the timetable is a kind of structure where the talks are sort of researchy and then possibly less researchy. So now you get a more researchy talk, but it's rather practical still. So I'm super glad to introduce Vasek from Masaryk University, our good collaborator and friend in the chess project. So Vasek, please.
Thank you very much, Dan.
One request. Eric used the word protection profile, and you are about to use the word security target. Can you explain what those are?
I will explain shortly what it is, and if you buy me a beer for every time I mention security target, I will be a very happy man. Okay, it's my true pleasure to be here in the morning and to share with you my background first. I am a retired cryptographer. I don't do cryptography anymore. I don't dare saying that I would do cryptography. And I dare speaking here about this stuff because I did standardization already in the previous century. I helped designing the original common criteria, namely the privacy classes and part of the non-repudiation. And I shall be mentioning here, as Dan asked, security targets a lot. However, I'll be focusing on the point of view how we certify new cryptographic mechanisms, new cryptographic constructions. And I originally wanted to lead the parallel of this talk together with subjective and objective evaluation of beer. Beer is, as we discovered in the chess project, common value between the Estonians and the Czechs, and many other nations share the love for this kind of beverage. However, since it's very subjective, the judgment of beer, I mean, more than cryptography, I decided to stay shy of the beer, and I shall not be hopefully mentioning beer anymore in this presentation. However, I also exercised a lot with one particular friend, and that is the good old friend that we are using for a couple of years, and that is ChatGPT. And ChatGPT, as we all know, is better than a crystal ball. Because crystal ball we could not have really used, we had to have an interpreter, and now if we understand the topic, we use ChatGPT. And if we understand the topic really well, we get very often frustrated, and we are learning where ChatGPT can help us and where it's really pointless. And if we are going into an area that we don't understand, then we are extremely happy with the results of ChatGPT because we cannot verify their validity. And I don't know who was behind coining the keyword of hallucination for tools of this kind, but after my experience for the past few weeks when I was preparing this presentation, I believe this is exactly the right term and the right verb to go along when describing the output of tools like ChatGPT. The other tool that I will be trying to sell you on a bit is a tool that we developed at Masaryk University, a tool called SecCerts that I also used for a part of my presentation. We have heard here and will be hearing more good arguments in favor of certification. And if we take a little bit broader scope than certification of cryptography or certification of security, we look at certification of IT products. We already have heard that what is behind is interoperability. We have heard of some aspects, or definitely clear aspects of quality assurance. Of course, market trust is closely tied to that and is definitely to the industry probably worth having a separate box on this slide. Compliance, and last but not least, competitive edge for companies who can score the first certifications and come with certified products first in the market. However, there are also negative aspects. Cost. We have heard cost being mentioned today, and it's cost in terms of money, people, and resources. Many people could do more inventive, more creative things than bothering with certification. It's time-consuming. And it creates a non-trivial maintenance overhead. Dan mentioned in the intro here the issue of maintaining the infrastructure and the systems that we introduce to support us in our daily lives. But the same goes for certification. Once we introduce a certification scheme of whatever kind, we introduce the requirements maybe for products to go along this line, then they will have definitely limited validity. They will have to be recertified. The standards themselves, the benchmarks against which the measurement is done, will be developing as well. And both these will feed the need for recertification and added costs in this dimension. Let's not forget that, unfortunately, certification also sometimes inhibits innovation, or partly inhibits innovation. People go, look what the customers want, and when we get the market into a position that the customers want a certified product, just to clear the tick box, to be compliant with scheme X or Y, then the customers want a certified product. They are not asking for a special feature that only we can do. They want a certified product. If the market goes in certain aspects this way, it is definitely hindering innovation. And last but not least, fragmentation of the market. Standardization and certification, if done in different regions, different countries, differently, will fragment the market, will create additional costs. Let's not keep forgetting about these negative aspects of certification while we get today enthusiastic about certification. And I am enthusiastic about certification, but I want to keep these negative aspects on mind, and I would beg you to do the same. So let me entertain you first with my first ChatGPT dialogue that, if I remember correctly, I was waiting for somebody in the middle of Tartu, the beautiful city in South Estonia, and had a coffee and did not have any beer, and started playing with ChatGPT to spend my 20 minutes of waiting. So my first question was, give me some real-world examples of famous product certifications. And you can imagine, in IT, of course, Wi-Fi, you can imagine FCC in the US. You can be surprised that one of the security certification schemes comes already in the top 5 that ChatGPT fires on you, and that is common criteria. I was surprised, actually, to be honest. Then Underwriter Labs, and another security thing. PDI DSS compliance, payment systems. So according to ChatGPT, this crystal ball of this day, among the top 5 certifications in IT, 2 of them concern security. So I am a security professional and academician. Then I asked what were the worst failures of the products that were certified. Some people may remember the 1994 and the new Intel processor of that day and the fun that it brought us in the mid-90s. All of you will probably remember this one. And here we go with the first security one, Heartbleed. I believe that all of you will remember that one. And another one, the very famous in the US, not so famous in Europe, failure of a wide government effort to provide a secure platform for sharing and doing some operations with healthcare data. And the old textbook example of the Terac radiation machine that we have been learning on already in the 90s. So again, out of the top 5 failures, 2 of them are of serious concern to us here in the room. Well, then I was more curious about cryptography, because I was asked to speak more about cryptography than security. So, of course, number 1 was Heartbleed. Number 2 was Roca, probably well known here in Estonia. And number 3 was Snowden-related generator allegedly co-sponsored in development by one of the famous US institutions with three-letter acronym. Then I was driven away by the hallucinating machine of ChatGPT and went to thinking, okay, how was the world of crypto when I entered it, and how was the standardization then in the early 90s? Well, it was living with the big standard of DES, and people in the academic community frowning about DES, complaining it's an algorithm from the 70s when a US government had a call, ran the competition and discussions only in the closed circles, tweaked some parameters for the better of the ecosystem, at least that's what we believe so far, and tweak other parameters for the good of the American government. Then, in the 90s, when I entered this beautiful world of cryptography, it was actually the effort, and here I'm speculating, I have to admit, of a US government-related folks trying to make sure that no better algorithm gets really standardized and the impact of DES remains in validity as long as possible. So this was the world of standardizing new cryptographic algorithms, at least to me, in the previous century. Still from the previous century, we have this new algorithm of AES. We speak of AES as a new algorithm, maybe not rightly so. It's a quarter of a century already, quarter of a century old algorithm. When the call came, there was some criteria for selecting this algorithm. At the very high level, the criteria went this way: security, cost, and characteristics of the algorithm and implementation. Those who followed the competition then, or read about it in detail, may remember that these criteria were twisted during the process. They were modified in the following way. Security was split into two parts. One was general security. Then the performance of the algorithm was more translated or more shifted towards the ease of the implementation in both software and hardware. Specific attention was given to the implementation attacks. This is the heritage of the 90s and Paul Kocher and other people inventing new things that were unknown up to then. And flexibility in decryption, keying, and other factors. These are not very different, but they are different. And many people then who believed in, or who were very rigid with respect to expecting fair competition, were actually pushing hard for the criteria not to be modified this way, although from the perspective of today, I believe that this is a modification in the right way. Recall the results of this competition. It was a US competition. Surprisingly enough for most of us in Europe, it was actually won by a non-US algorithm. Those who are old enough to remember that competition, this was a shock for the community actually. And it was an algorithm that out of the finalists in the competition was not carrying the label high security, but the lower label adequate security. And algorithm, to be honest, that had very nice, very convincing performance advantages, both in software implementations as well as hardware implementations. There were more secure algorithms in the competition. Some of them were much better in hardware, or had a clear potential to be better in hardware. Some of them had potential to be much better in software. But this was a reasonable compromise with which we are living for 25 years, and so far, so good. Then I went back to ChatGPT, and here I got toasted. I spent several sessions under my different IDs and different logins with ChatGPT because I was not happy with the results that I was getting, because I was not asking about the archaeology of security and cryptography. I was asking about what's going on, what's the hot stuff on the boilerplate. And I was getting things that I selected here are the reasonable ones. I got about 2 to 3 times more of nonsense and blurb for the journalists. Then I left ChatGPT, and we have heard today about some schemes, and not all of them have been mentioned. So I want to mention here several schemes with which we already have been living, with which we are learning to live, and with which we will have to learn to live. And I don't want to comment too much on these schemes, while most of us in this room may be happy, because we'll have a lot of work to do. If I had a security company, there would be a really nice business in Europe for a few days. People who are on the other sides of the table may be not that happy. We keep hearing of the words of overregulation, costs, and many good arguments why maybe this plate is too excessive. Future will tell. I don't want to comment on this anymore, and let me focus on cryptography. One of the relevant things that comes from very recent past is the new update of FIPS 140. While we pay attention to version 3 now, and for very good reasons, we still should keep on our minds that until late next year, the validity of version 2 is still in place for some use cases. And attention to this US standard is, in my view, and my take on the European discussions, going a little bit down, and maybe rightly so. Maybe we do a mistake. Maybe this standard will be as important as it used to be in the past 20 years. We shall see. Before I get into the final parts of my discussion, let me guide you through the common criteria, important concepts that I will need for the last dozen minutes or so. And that is the target of evaluation, that is the stuff that we want to evaluate, protection profile, the, let's say, subset, typically specific subset of common criteria along which we want to drive the evaluation, and security target, the ultimate concept or aim, sometimes we can view it as a claim, what our product is actually achieving. And we know, do I have a pointer? Nope. We know, or if we don't know, I'm telling you, that the evaluation is not done in a way that a vendor throws a product on the table of the evaluator, but the product must be provided with a lot of accompanying effort and documentation, and together with the security target, that is the theoretical claim, this is what my product does. And the evaluator is doing the job of evaluating whether the product does this thing. Okay? So the security target is extremely important for us. It's important to me as well for the beers, of course. And where the security target can do it, I believe it should do it, goes along and stems from the protection profile. However, for the modern technologies, and we want to discuss here modern cryptographic methods, it may be tricky and sometimes, especially in the beginnings, not possible. Oh, sorry, I jumped back. Let me take the first case, homomorphic encryption. All cryptographers are enthusiastic about homomorphic encryption, I would say for a quarter of a century. Longer than AES, if I recall correctly, or about the same time. Homomorphic encryption, at the moment, is, if my information is correct, and here I went beyond ChatGPT, is not in any government-approved set of algorithms. And just last year, only two algorithms came out in the part 6 of this ISO standard that I'm quoting here. There are a few reasons for that, but we see in the industry a clear interest to start working with homomorphic constructions. We see first potential customers testing and playing with the thing. And we see also the first products that get certified. First product, to be honest. If I checked correctly, and I rechecked this week, we have one product that is certified. And the certification, I did not read every single line, but it left me puzzled, and I believe that when I will go through this slide, it will leave you puzzled as well. On one hand, it says that the target of evaluation, the product that is evaluated, the thing that the vendor is bringing, is a homomorphic encryption engine for database queries. My heart and my soul would want to say, wow, that's better than beer, isn't it? Well, then you read this. And I took the quotations, so sorry if I'm harming a soul of our vendor's interest here. It was not intentional. You were the only one having this product, and I went to analyze this document that is available. And that it basically says that it's evaluated as software application only. Maybe I should have underscored this. And the homomorphic encryption techniques, blah, 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 are left outside the scope of this evaluation. Okay, this is already interesting. What's behind? On one hand, it says the target of evaluation is the homomorphic encryption library version XYZ. So it is, the library is evaluated. On the other hand, it says specifically the excluded functionality is the homomorphic encryption process, including the algorithms, uses, and the security strength of the resultant ciphertext. If I'm paid as a consultant, am I recommending my client to use this? I don't know. Definitely not for security reasons, and definitely not as this being a competitive edge. And reading of these certification documents will leave you left puzzled. If you focus on the cookbook, it should go along, and the cookbook is generic application software protection profile. So protection profile along which you can evaluate security meters for monitoring potholes on Czech roads or anything else. So much for homomorphic encryption. And here we speak of a construction that is, for me, the first things really like quarter century. Not think of past 5 years. Then we have another interesting area, and that's multi-party computing. And multi-party computing, I will divide into two branches. One is with short or relatively short data, and that is for crypto key operations like signing. For that you will find quite a few products, and supported by security targets. And you will see also situations that the security target is a little bit shy of the MPC aspect. It's done internally to secure the keys, and the conformance is claimed to cryptographic protection profiles that basically do not consider much of MPC aspects. And I can understand. There are so many protocols, and so many more are being developed and still evaluated. And we don't have any real standards along which we would robustly build the entire certification ecosystem. And then we have the other branch of multi-party computing, and that is working with data that is bigger than standard cryptographic keys. Typically here we have solutions that go for privacy-preserving data analysis. And here we come into even more tricky area, because we work with different aspects than the aspects of cryptographic key protection. Cryptographic key protection is a business that is very well known. It's understood clearly in lessons learned in a very hard way, where it fails, what gets screwed, what threats are there. For bigger data operations, for true multi-party computing, it's trickier, and developing the right thread model is unfinished business. I have not seen a paper that, except for just one particular case, one particular thing, really would show me a thread model that I would happily read, agree with, come back to that paper or white paper 1 week or 1 month later, and still agree with that thread model after thinking about it. And on top of the two slowdown factors that I see in that area, it's also the performance overhead that are tricky and that play against the fast deployment in the industry. So to conclude my presentation and my discussion, I come back to my crystal ball of 21st century. And this was really not pleasant. I had a discussion with ChatGPT after putting through results of previous discussions. And I asked about the vision of certification of new products and standardization. I got this answer, which is okay. I think that nobody here in the room will disagree with that. I got this answer that will not make me unhappy, but will not help me probably much. And I sort of felt like this. If somebody gets me this keyboard, it's a keyboard that's useful for certain situations, but not for general work with a computer. So here the crystal ball actually, or work with ChatGPT, led me to the thinking that as a crystal ball of the sense of looking into the future, it's still a rather hopeless tool. And when considering the aspects of certifying new cryptography, I thought of non-cryptographic takeaways that I'm putting forward. And one is really going back to the basics and figuring out why exactly do I want to certify my product. Do I do it to make one particular customer happy? And if so, it's perfectly right decision, but I should stick with this, and I should keep this reasoning, this decision on my mind, even in 1 year or 2 years, when the situation maybe changes, and maybe then my position will change a little bit, and I will want to go ahead and look into other aspects. Of course, we have a trouble with quickly developing ecosystem, yet we should try to map the ecosystem, and we must make sure that we map it well. And last but not least, the world is not perfect, we are not perfect, we are making mistakes. It's definitely worth doing things in order to avoid the mistakes. However, we should not really fear them and inhibit them from us doing what we want to do. With that, I want to thank you very much for your attention, and to add a little bit of my games with the crystal ball, the last image on this slide comes actually from ChatGPT. I got ChatGPT actually repeatedly stuck on regenerating a different image when asking for the requirements. I leave it for the coffee break to discuss where I got it stuck. And with this, I want to announce, beyond the chess project, that is ongoing project on really interesting collaboration in different 6 areas in cybersecurity, a project that is called CCAT. That's what the logo shows, the CCAT. project that we start with the consortium here from Estonia involving two partners, University of Tartu and Cybernetica, where we will be evaluating 6 very specific tools, some of them concerning cryptography, namely TLS, cryptographic certifications, certs, cryptographic evaluations and certifications for special purpose hardware like smart cards or TPMs, scrutiny, and ALVI, a tool for embedded software security. We'll be evaluating these, and we will be very likely, in one way or another, reaching out to you if you work in an institution that would want to put their security a little bit forward, try and help us improving these tools, and in favor getting our assistance in helping to verify your TLS deployment, your smart card deployment, or your considerations in the world of security standards. Many thanks for your attention.